We'll start with a refresher of the concept of interfaces. As you probably know, an interface is not a class, but it's a set of requirements for classes. Classes can choose to conform to one or more interfaces. The reason they would want to do that is so that they can partake in services. A service provider can make a promise to a caller of one of its services, the promise being, if your class conforms to this interface, then I'll perform the service. That's all pretty abstract, so let's look at an example. Consider arrays.sort. Arrays.sort will sort an array, provided that the element class of the array conforms to the comparable interface. If you have an array of elements that are comparable, arrays.sort will sort them. If they're not, then it won't. Here you see the definition of the comparable interface. It has a single method called comparator. For a class to be comparable, it has to be willing to compare objects with other objects of the same type. As it happens, this interface is a generic interface. It has a type parameter, namely the type of the other objects with which one wants to compare oneself. And here you see the type parameter in the parameter list. For a class to conform to this interface, it simply has to say, A, I am comparable, and B, it has to provide an implementation of the comparator method. We see that here. So the employee class implements the comparable of employee interface. An employee object is willing to compare itself with other employees. And here we have the code of the comparator method. This one rather crassly compares employees by salary. When we have that, we can make an array of employees and pass it on to arrays.sort, and the array will be sorted in the order of the salary. Now let's look at the other side of the service provider. In this case, the service provider is the arrays.sort method. What does a sorting algorithm do? A sorting algorithm is presented an unsorted array, and then it keeps comparing elements and rearranging them in some way that maybe you studied in an algorithms course. But the essence of sorting is to find out whether elements are out of order. How does one know whether they're out of order? One invokes the comparator method on two elements. One here is the receiver parameter, and one here is the explicit parameter. And out of order means that comparator returns a positive number, and in that case, we need to rearrange. But how does the compiler know that comparator is even a valid method for the array elements? That's where interfaces come in. As long as AI is an instance of comparable, then AI has a comparator method. And how do we know that AI is an instance of comparable? That is in the method declaration of sort. When you look at the Java doc for arrays.sort, you will see this method declaration here, which looks a little scary because of the generics, but it says that T must be a comparable type. Never mind the question mark super T. Basically, it means that T belongs to a class that implements comparable with just the right type parameter. Let's look at a bit of sample code here. Here you see the employee class, just standard boring employee class with a name and salary field. It implements comparable of employee. And over here is the comparator method that you've already seen. Here we're putting this class to use. We're making an array of 3 different employees. We're calling sort on it, and then we print the sorted array. Let's run it. Over here, you see the array is now in sorted order. First, the smallest salary, then the next smaller one, and over here, the largest one.